Welcome to this video on solids. In this video we're going to look into the surface area and volume of 3D solids. So first let's look at a cuboid. So cuboid is a rectangular solid with 6 faces. So you might have seen this also seen this. You might have, this is also called as rectangular prisms. So let's say this is cuboid. And the cuboid is measured by its length, breadth and height. If this is length, we say this is breadth and this is height, and these are the 3 measurements of cuboid. So following are the things that following are the measurements of cuboid. So the first measurement is, we say, hey, the total surface area, the total surface area is the area of all the 6 faces. So you can see that this is one face, so that one area of this face is L into H, but then this face is in the back side also, so we can say this is 2LH plus, then you have the second face, which is this one, and which you have 2 faces, so you can say this is 2HB, and then the third one you can say is the top face, right? So this face, so this face, this is this length is L, and we know that this depth is B, so this would be 2 times LB, because you have one in the top and one in the bottom. So 2 times LB. So overall you have, this will add up to 2 times LH plus you can say BL plus, or I'll go in the same order to avoid confusion, HB plus LB, right? The second thing that you need to know for a cuboid is a lateral surface area. So a lateral, when we say lateral, lateral surface area, so when we say lateral, this is we mean sum of area of all the 4 walls. So you have the wall 1 and the wall 2, and this is wall 1, wall 2, and the wall 3 is a backward, which you can't see, and the wall 3 is this side, 4 is this side, which you can't see. So if you're just talking about the lateral, we are not talking about the top and the bottom, so this is not included, and the bottom is the bottom is not included. Okay, so the top and bottom not included. So that means that we are just eliminating this quantity, 2LB. The other things remain. So that is 2 into LH plus HB. So that is a lateral surface area. And the third one is the volume. The volume of this cuboid is given by the length into breadth into the height, L into B into H. To visualize this idea of volume, let's look at a very simple cuboid. So here is a simple cuboid, and L is 3 units. We have 3 units there, and this side is 2 units, and so this is 2 units, and the top we have 3 units up, right? 3 units. So now if you want to find out the total number of, and let's assume that each of this cube is 1, 1 and 1. So this is, we call it as 1 unit cube. It's also written as 1 unit cube. Now if you want to find out the volume, we are finding the number of unit cubes. So the number of unit cubes in the first layer, let's see the number of unit cube in the first layer, which is which is this. So it is 1, 2, 3. Let me use a different color here. Okay, 1, 2, 3 into 1, 2. So we have 3 plus 3, which is, you can't see the back side, so there are 3 more cubes in the back side, so 3 plus 3, or in other words 3 into 2. So 3 into 2, so this is 3 into 2. And how many such layers are there? 1, 2, 3 layers are there. So you can say 3 into 2 into 3. That's the total number of cubes which are there, and that will be equal to 18 cubes. And this is what we write as 18 unit cube, right? And that's where the L into B into H is coming. So let's say if this is L and this is B and this is your height H, so we can say that, hey, L into B into H is a volume, and the unit is, we say it is unit cube. So what this unit means is, this can be centimeters, meters, or whatever it could be. So if I say this is 3 centimeters and 2 centimeters and 3 centimeters up, then the volume would be 18 centimeter cube. So that unit will be replaced by centimeters if these quantities are in centimeters. Okay, let's look at the diagonals of a cuboid. So here in this diagram, in the first diagram, you can see the various diagonals of the cuboids. So let's mark them. So the first one is AH, and the next one is ED, right? So you can see from E to D, and the other diagonals are GB and CF, right? So from C to F. And cuboid has an interesting property that all the diagonals are equal, right? So they have 4 diagonals and all the diagonals are equal. Now if we find one of the measurements, then we can find the others. So let's try to find AH. So in that cuboid, so maybe I need to make it look the same. So yeah, so assume these are the same cuboid, or maybe a different cuboid, doesn't really matter, with L, B, and H height. So let's find AH. So let's first take triangle ABD. Though it doesn't look like in this isometric projection, but your AB and BD are perpendicular. So your diagonal AD would be given by AD squared is given by L squared plus B squared. So once you know that diagonal, then you can take triangle AHD. So that's a red triangle that you see. So let me use a red color in triangle AHD. You have AH squared is AD squared plus HD squared, right? That's equal to AD squared is L squared plus B squared. So I can say this is L squared plus B squared plus HD is H squared. Or in other words, AH or HA is square root of L squared plus B squared plus H squared. So that's diagonal of a cuboid. It's the same for all the diagonals, L squared plus B squared plus H squared. So that's the diagonal of the cuboid. So I hope you enjoyed this video. See you in the next one. Ciao. Bye.